Today we're doing the fourth notes from Graphs and Functions chapter, and we're going to be talking about slope-intercept form. So slope-intercept form is y equals mx plus b, and I talked about it a little bit in the video from yesterday on that third set of notes. So remember, m is your slope and b is your y-intercept. Whenever you are graphing, you always graph the y-intercept first, and then you use the slope second to create your second coordinate, and 2 coordinates is sufficient to create a line. So moving on to first set of examples for today. In order to graph, I need to solve for y. So this is why we did those literal equations in that first chapter. I need to get y by itself, so to do that, I'm going to add 3/4 x to both sides. So after I move that over, I have y equals 3/4x plus 2. Now that I have that, I need to identify my m and my b. So my b is 2. So that's your y-intercept, and your m is 3/4. I'm not going to write that out every single time. Again, this is a review, but just to kind of highlight that. So now that I have that information, I'm going to plot my points. So my y-intercept is 2, so we go up 2, and we'll plot the dot on the y-axis. From there, I'm going to use my slope of rise over run. So I'm going up 1, 2, 3 over 1, 2, 3, 4. I could also travel down and to the left, so I could go down 1, 2, 3 and left 1, 2, 3, 4 from that original coordinate. You don't really need to do that once you have 2 coordinates that's sufficient to create your line. And I'm going to connect them, and we're going to put arrows on either end because it's going to go forever. Going back to letter B, again, we need to solve for y, so my first step would be to subtract 5x over. So when I do that, I get 2y equals negative 5x plus 10. If you wrote on your paper 10 minus 5x, that's also fine. Just be conscious of which one is the slope and which one is the intercept. Now to get y by itself, we divide by 2. You need to divide everything by 2. So I have y equals negative 5 over 2x plus 5. Notice I didn't divide 5 over 2 and write that as a negative 2.5 because that represents your slope. So I want to clearly see what my rise over run is. I don't want it as a decimal. So my b value is the 5. So I'm going to go up 5 on the y-axis. And then my slope is the negative 5 over 2. So I'm going to go down 5, right 2. I don't really have much space left to go up 5 and to the left 2, so that's why I chose to go down and to the right. Now that I have that information, I connect my dots, and we put arrows on either end. Just to kind of tie things in that we did from last week, the domain of both of these pictures is negative infinity to infinity, and both of the ranges are negative infinity to infinity because these lines are traveling forever in both directions. So you have some practice problems to try, and now we're going to go over horizontal and vertical lines. So a line that says y equals negative 6, we would go down to negative 6 on the y-axis, and you would draw a horizontal line. Might barely fit on my graph. So y equals are always horizontal. X equals are your vertical. So I go over to 5 on the x-axis. So 1, 2, 3, 4, 5. And I put a little dot. And there is my x equals 5. Again, just to review that is a slope of 0. This is a slope of undefined. Nope, totally got that wrong. I was just kidding. I was testing you guys to see if you were paying attention. That slope is 0. This slope is undefined. Again, take a moment. You have 2 practice problems to try. Make sure you're okay with graphing those. So next thing we're going to discuss is parallel and perpendicular slopes. So parallel slopes are when the slopes are the same. The slopes are the same because your parallel lines never intersect. So that's why the slopes have to be exactly the same. Perpendicular slopes are opposite reciprocals. So what that means is if the fraction was positive, it's now negative. If it was negative, it's now positive. And reciprocal means that the fraction flips. So for example, if you had a fraction of negative 1 over 2, it now becomes a positive 2 over 1. Perpendicular lines intersect at a 90-degree angle, so they create a 90-degree angle. So for this next one, this is just making sure you understand the concept. So they give you 2 equations and they want you to identify if they are parallel, perpendicular, or neither. This little symbol that looks like an 11 is your symbol for parallel. The upside down T is your symbol for perpendicular. So for letter A, you just have to identify the 2 slopes. So for the first equation, 2 over 3 is your slope. For the second equation, 2 over 3 is your slope. So we would say that these lines are parallel because the slopes are the same. In letter B, I can see one of the slopes. I know one of the slopes is negative 2. But before I can proceed, I need to get y by itself in that second equation so I can determine the slope. So I have to subtract 2x from both sides. After I do that, I get y equals negative 2x plus 8. And now I can identify my slope, and in this case it's negative 2. So again, the slopes are the same, so this would be an example of a parallel slope. So now the next thing and last thing that we're going to practice today is kind of putting all these concepts together of graphing and parallel and perpendicular. So they want you to graph the line that meets the given conditions. So it says passing through the coordinate 0, negative 1, and it needs to be parallel to the equation y equals 3x plus 4. So let's start by plotting the point 0, negative 1. So 0, negative 1 is right here. And when I look at this equation, I need to obtain the slope. So the slope is 3. So I'm just going to write that the parallel slope, so I write slope and I use the parallel symbol, is 3. So from that point that we plotted, we're going to go up 1, 2, 3, and over 1. And I'm going to go again up 1, 2, 3, and over 1. Now, nowhere in the directions does it say you have to graph the original line. I always think it's a good idea to do that so that way you can compare the two and make sure they are indeed parallel. So now I'm going to graph the original line. So I'm going to go up 1, 2, 3, 4 to my y-intercept, and I'm going to use my slope of 3. So I'm going to go up 1, 2, 3 over 1, and I'm going to go down 1, 2, 3 and left 1. Now you get a nice visual. You can clearly see that these 2 lines are parallel, meaning they're never going to intersect. So that is a great way to kind of check your work to know if you're doing these problems correct. So our last one for today, again, same idea. So again, there's that upside down T, so that's the symbol for perpendicular. So they want you to graph a line that's perpendicular to the equation 3x minus y equals 4 at the y-intercept. So again, we're going to take this equation right here and we're going to solve it for y. I can't really do much until I get y by itself. So my first step is going to be to subtract that 3x over. So now I have negative y equals negative 3x plus 4. And then I need to divide everything by negative 1 to get y by itself. So y equals a positive 3x minus 4. So now that I got the equation by itself, I now need to graph it. So let's graph the original one. I'll do my original one in red, and then I'll make this the newer one in the second color. So I'm going to go down 1, 2, 3, 4. and put a dot on my y-intercept. And I'm going to go up 3 and over 1, up 3 and over 1. So that's my original line. Whoa, bad. All right, let's try that again. There we go. All right, so now let's graph the final answer. So the final answer is saying they want a line that is perpendicular at the y-intercept. So the -4 is the y-intercept. So I'm, again, going to put a dot at the -4. And then they want me to use the perpendicular slope. So the slope right now is 3, which can be considered a 3 over 1. So the perpendicular slope is going to become a -1 over 3. So don't forget to flip that fraction. So from the -4, I'm going to go down 1 and to the right 3. I could also go up 1 and to the left 3. So up 1 and left 3. And by doing this, you should now see 90-degree angle is being created between those two lines, and that's how you know it's perpendicular. If your graph right now looks like a pair of scissors that aren't open all the way, that means you use the incorrect slope. So that is all for today. Again, there's some more practice problems for you to try.